Well, good morning. I hope you guys are ready for a great week. I know I sure am. We are going to be looking at continuing along with our equations, solving equations with variables on both sides. But today we're going to be throwing in two new layers to it. The first layer is what happens with our equations when we have rational numbers. I'm going to show you some shortcuts there that we saw, I think, earlier in the year. So I'm just going to be reminding you about them. And then the second is what happens when we have to actually write the equation given a situation. So if you can practice with both of those things today with me, then you should do great when we get around to doing it on our lesson practice. So let's just jump right in. The first thing that you'll notice about this problem that I'm giving you is that essentially we still have two slopes. We still have two y-intercepts, but of course these aren't just integers anymore. These are now rational numbers. And before you grab your phone and think, oh, the only thing I can do is photomath this and move on, let's think logically for a second. There's one step that we can take that's going to get rid of all these fractions for us, and that's where I want to look to simplify these rational number expressions first. If we notice, we have 7/10, 3/2, and 3/5, and all three of these fractions have a common number that the denominators would all go into. In other words, they all have, a least common multiple. So that question would be, if you were going to get a common denominator, basically for 10, 2, and 5, what would that least common denominator be? Well, obviously, it would be a 10. And so what I'm going to do is I want to multiply this entire equation set by 10 over 1, okay? And some of you have seen already what this is going to do. So let's go ahead and distribute this 10 over 1 to every single term here. When I do 10 over 1 times 7 over 10, notice my 10s cross cancel, and I'm left with 7n. Then let's look at the next one. 10 over 1 times 3 over 2, my 10 and my 2 cross cancels. My 2 goes into 2 one time, 2 goes into 10 5 times. 5 times 3 is 15. Let's move along. 10 over 1 times 3/5. Well, 5 goes into 5 once, 5 goes into 10 twice, and 2 times 3 is 6n. And then, of course, 10 times 2 is 20. Well, now we're just down to our old normal problems from last week where we're going to combine like terms to solve for, in this case, n. I'm going to add a negative 6n to both sides. That's going to leave me with n plus 15 equals 20. I'm going to add a negative 15 to both sides, and n is 5. Okay? So no problem. Really, this simplifying step is our only additional step, all right? So if you've got your book with you and you open up to page 468, both of these problems are in your book. What I'd love for you to do is to press pause on this video, go over to page 468 and see if you can work both of these out. At least see if you can find what that common denominator would be, and then come back and press play on this video and match what you did to what I'm doing in this video. Okay, so at this point you have gone ahead and worked them out. I'm going to work them out and we'll see if we match. So I look through here and it looks like my denominator is 7, so that's easy. I'm going to multiply this whole thing by 7, okay? So 7's cancel out, 7 and 7 become 1. I'm left with k. 7 times 6 is 42. These 7's cancel out and I'm left with 3k, and 7 times 4 is 28. So this looks awesome. I love this. Subtract k, I've got negative 42 equals 2k plus 28. I'm going to subtract 28, which is the same as adding a negative 28. I've got 70, negative 70 equals 2k divide by 2, k is equal to negative 35. All right. And then let's check out our other one. I come over here, I've got 6, 2, and 4. If I was going to find a common denominator for 6, 2, and 4, I mean, I've got options. I could do 12, I could do 24, I could even go larger than that, but I want to keep this as simple as possible. So I'm going to use the smallest number that 6, 2, and 4 go into, which is 12. All right, so let's start going through here. 6 and 12 cross cancel out, and I've got that 2 up here now. 2 times 5 is 10y. 12 times 1 is 12. Okay, now watch your signs here. A negative times a positive is a negative. 2 goes into 2 once, and it goes into 12 6 times, which makes sense. Half of 12 is 6. And then 4 and 12, of course, 4 goes into 4 once. 4 goes into 12 3 times, leaves you with 3. And that one is so much easier to solve than the other one, but they're equivalent. Okay, and then I'm going to add a negative 12. We've got 16y equals, let's see, negative 9. And then divide by 16, y is equal to negative 9/16. I have a feeling I maybe made a mistake in here somewhere, because not that negative 9/16 can't be an answer, but it seems a little wonky compared to some of the other answers I have. Tell you what, I'll go back and take a look at this one, but the first person that can text me or email me and tell me what my mistake was on number 4 on 468, I'll give you a bonus point on the quiz this Friday. So shoot me a text if you can tell me what it is. That'd be awesome. All right, so now let's move on. This is probably the part that'll seem a little trickier to some of us, but it's still very doable. I'm on page 468, and I'm looking at example number 2, and I'm just going to kind of bring this problem over here from our book, okay? If you notice, it says that Javier walks from his house to the zoo at a constant rate. That language should sound familiar to us, okay? After walking 0.75 miles, he meets his brother Raul, and they continue walking at the same constant rate. So when they arrive at the zoo, Javier has walked for 0.5 hours, and Raul has walked for 0.2 hours. All right, so what rate in miles per hour did they walk to the zoo? All right, so really we're wanting to translate this into an equation. And what's important here is that it says they continued walking at the same rate. That same rate, that's where your equal sign is, okay? If you notice that Javier walked at for this amount of time, all right, and then he joined his brother, whereas the other brother walked this distance, okay? So now that we have these set up together, it sets us up really nicely to look at our other shortcut that we're going to use. And we've used this one before. This is where we're going to multiply by a power of 10 so that we eliminate those decimals. I know that we've done this before earlier this year, but this will just be a little bit of a reminder. If we look here and here and here, it looks like the 0.75 has the furthest to go to actually eliminate that decimal. It needs to go 2 places, so 10 squared is 100. If we just go through and multiply everything by 100, we'll have those nice, neat numbers to use to solve for this problem. Okay, and then they go on in the book and just sort of explain those steps. I won't waste your time in explaining those steps, but this is sort of where we want to go next, is not only using the shortcut to eliminate the decimals, but then also writing the problem given to us in the book. All right, so let's flip over to 469. Make sure I've got mine here. 469 is talking about the 2 aquariums that Logan has, okay? In fact, I'll just kind of fold this paper up and put it up here so we can take a closer look at it, okay? So this is in your book. I know this is super small to see on the video, so just open up your book. Logan has 2 aquariums. One aquarium contains 1.3 cubic feet of water, and the other contains 1.9 cubic feet of water. The water in the larger aquarium weighs 37.4 pounds more than the water in the smaller aquarium. Okay, so more than, it looks like we're going to be adding. So when I look at this, I'm going to translate this down to our equation so that I can solve it. I see that 37.44 pounds more than the water in the smaller aquarium, okay, is the same as the water in the larger aquarium. All right. Well, now it takes we just have to look back in our problem. Which one of these clearly is the smaller aquarium? Well, it's the 1.3 cubic feet. So 1.3x. All of this together is the same as what's in the larger aquarium. Okay, so write the equation, which is what we did, and then we just need to find the weight of 1 cubic foot of water. So I need to solve for x. Well, this looks like kind of a train wreck, so I want to go through and multiply by a power of 10. I'm going to multiply every term by a power of 10. This one looks like it just has one place to go, one place to go. This has 2 places to go, so I'm going to use that as my guide. There's my 2 places to go. Once I've gone through and multiplied, you'll see I've simplified to this. 3744 plus 130x equals 190x. Now, if we were sitting in class right now, we'd probably grab a calculator to go ahead and solve this, but I really do want you to see that this isn't that bad of a problem, okay? We're going to subtract 130x from both sides, and we're left with 3744 equals 60x. All right, divide by 60 to solve for x. And again, I'm sure most of you, if you haven't done it already, have grabbed your calculator to do 3744 divided by 60. But because you guys are honors kids, you should be able to see that this really isn't that big of a deal. 6 goes into 36 6 times, right? 6 times 6 is 36. So there it is. Oops, 1, okay? And then 6 goes into 14 twice, right? 12. Add a decimal and a 0, and easy math. 6 goes into 24 4 times. So x is 62.4, looks like, pounds. Okay? So pretty straightforward, not a big deal. Alrighty. Okay, so what I want to do is I'm going to stop this video and then I'm going to make a second one, and this is going to give you a little bit of time to come over here to page 470. 470 is our guided practice. I'm going to actually make a second video that's going to work through the guided practice with you so that you have the best resources possible to be able to practice this when accuracy counts on the assignments on these. Okay, you guys? All right, so run on over to page 470 and I'll see you in the next video.